Reactions Part 2, Neutralization Reactions. So this is one of the reasons why it's really, really important for you to be able to recognize an acid and recognize a base. Because if you don't, you're going to be derailed right now. So please refer back to the screencast on identification. So what we're looking at is, again, we're looking at an acid, which is from table K, or it looks like something from table K, and then a base, which is from table L, and it looks like something from table, or it looks like something from table L, water, and an ionic compound. So any ionic compound that makes sense in the formula. So let's take a really basic type of neutralization equation, which is hydrochloric acid and sodium hydroxide. So if you have stomach problems and you take Tums or Rolaids or whatever, what you're doing is you're neutralizing your stomach acid, which is HCl. Anyway, neutralization reaction means that you're taking the H and the OH and you're reacting them together to produce HOH, also known as H2O, right? I'm just writing it in a different way. It's just easier to balance the reactions if you write it as HOH. All right, and then whatever's remaining, right? So we have an Na remaining and we have a Cl remaining. So our Na and then Cl. So this is a very basic neutralization equation. So you must have an acid, you must have a base, must make water, and then something else. Okay, so let's take a couple more challenging ones. So let's take H2SO4, which is another acid. And I don't know, let's just take magnesium hydroxide. And what we know, again, is they must make water, right? So I'm just going to write HOH. I'm not going to worry about the quantity yet. I'll balance that at the end. And then whatever's remaining, which is the Mg ion and the sulfate ion, so I would write MgSO4. Those are the charges. And now I'm going to balance it. I have two of these and two of these. Oh my goodness, I can't believe I wrote it like that. That is so bad. It should be like that, outside the parentheses. And you have a 2 there. Okay, let me give you one that confuses students, but it really, try not to panic about it. I'll just write the, obviously it doesn't matter if I write the acid or the base first, but let me give you this one, which is the ethanoic acid. Sorry, all that wind outside today is distracting me. And then I'm just going to make, we'll just say KOH. So if you go to table K, you can see that this is an acid and this is a base. All right, so even though that acid looks really weird, if you go on table E, you will note that there is something that looks like this, and this is called the acetate ion. So even though it's complicated and big, it acts just like a SO4 or NO3 or whatever. So what I'm looking at with this reaction is I have a hydrogen here, that's the hydrogen that's going to be ionized, and then I have the OH here, so I'm going to be making HOH, water. And then my K is my positive ion, and then this is my negative ion. So I put the K here, +1, oops, and then CH3, COO, and that's fine, I can write it like that. And actually it's balanced already. So again, we'll be doing a little bit more practice, but hopefully that made sense. But the biggest thing that you need to know is you need to be able to recognize an acid and a base. Once you see an acid and a base in the numerator, in the reactant side, it's going to produce water and then whatever's remaining.